Welcome to another installation of Teach the Doc. And this episode we will be covering gases. And this is Mary Rachel Pritchard, otherwise known as Rachel Pritchard. And let's go ahead and take a look. If you need to pause and see what the questions are, here are all of the questions we'll be going over. And let's begin. First question, consider the reaction between hydrogen and oxygen to produce water as shown. We have our equation here. What volume of water will be produced at STP from the reaction of 0.200 liters of hydrogen and 0.500 liters of oxygen? So we are wanting to find the volume of water. Now, we are given 0.200 liters of hydrogen and 0.500 liters of oxygen. So what we need to do is find out what our limiting reactant is first. So we'll start out with hydrogen. 0.200 liters of hydrogen. Set this up so that we can do our conversion. 1 mole of H2, and since we're at STP, 1 mole is the same as 22.42 liters of H2. And if we do the math on this, 0.200, well, I like to do it this way, 1 over 22.42 times 0.200 equals 0.00892 mole of H2. Now we'll do oxygen, which is 0.500 liters of oxygen. And we'll do the same thing here, 1 mole, O2, 22.42 liters, O2. And the math on that, 1 over 22.42 times 0.500, 0.0223 mole of O2. So this is our smaller number, so this is our limiting reactant. I want to make sure I'm still recording here because my screen is continuing to go dark. Yep, we're good. Okay, now we are going to check out our molar ratio here. So we want to know how much water, so that's H2O, and 2 moles of H2O for every 2 moles of H2, our limiting reactant. And that was 0.008, we'll go that far, 0.00892 moles of H2. 0.00892 times 2, multiply across, 0.0178, although actually that's wrong because this is 2 over 2. So this is really just times 1 equals 0.00892 moles of H2O times 22.42 liters. 0.00892 times 22.42 is 0.1999, or we could say 0.2 liters of H2O. And that is our answer for number 1. Number 2, consider the reaction between zinc and solid and hydrogen chloride to produce aqueous zinc chloride, and hydrogen gas is shown. Balance first. How many liters of hydrogen gas at STP will be produced, hydrochloric acid, when 4.75 grams of zinc react with an excess of hydrochloric acid, HCl? There it is. Okay, so first we need to balance our equation. So let's see what we've got here. ZnHCl, and we'll do the same thing for the right side. And it looks like we've got 1 zinc, 1 hydrogen, 1 chlorine on the left side. On the right side, we have 1 zinc, 2 H's, 2 chlorides. So we need to balance these sides. So we know we've got a 2 on this side, so we need to put a 2 over here on this side as well. That's a 2. So now we have 2 H's, 2 Cl's, and 1 zinc. And I think that we are then balanced because on this side we have 1, 2, and 2. So that is the only difference that we needed to make to balance that equation. So now we need to find the liters. And we're given our molar ratios and our mass of zinc, which is 4.75 grams. So we need to figure out how many moles we have. So we'll go 4.75 grams of zinc. And to turn that into moles, we need to see what the mass of zinc is. And zinc is, don't tell me where it is. 65.38 grams. So do our math here, and we'll do 1 over 65.38 times 4.75 equals 0.0725 moles of zinc, or 7.27 times 10 to the negative second moles of zinc. So now that we have that number, and we know that we're using STP numbers, we will take this, we can really just take the 0.0727 moles of zinc, multiply it by 22.42 liters, which is the same amount in a mole, and this will give us our liters. Multiply across, and we get 1.63 liters of, how many liters of hydrogen gas will be produced? H2, and that's because this is a 1-to-1 ratio. H2, there's 1, zinc, there's 1. So we don't really even need to do the molar ratio on this to know that this is the correct answer. So that is our answer. Next problem. What is the density of nitrogen gas in grams per liter at 25 degrees Celsius and 0.0850 atm? Use the gas constant of R, which is 0.0821. Now, what is the density? So we know that density, oops, hang on, let me pause this. Baby's awake. And we're back. Okay, so the first thing we're going to do is take the values that we have been given. So we have T, that's 25 degrees Celsius plus 273. 25 plus 273 equals 298 Kelvin. We have our pressure, or P, which is 0.850 atm. And we need the volume, and we don't have the number of moles, or the amount. So what we're going to do is go PV equals nRT. Well, we've got our T, we've got our P, we need our V and our N. So what we're going to do is isolate this down. PV equals nRT. So we want to get V by itself, so we'll divide by P. And we'll have V equals nRT over P. That's our first equation here. And then we also want N, and N is mass over molar mass. So, moles over molar mass. So N over M, N equals M over MM. Molecular mass we know from the, sorry I'm slow at this part, this is not my forte obviously. So H is 1.008. And we're going to have 2 of those for H2. 1.008, and I like to be precise, so we'll use the calculator on this. 2016. Oh, wait. No, we're doing N, not H. Read, Rachel. N2. Nitrogen gas. So N is 14.007. Correct this. Times 2. And that is 28.014 grams of N2. So we'll substitute for N and V equals nRT over P, and we're going to divide by N, or by M on both sides, because we're trying to get this, and we'll get V over M equals RT. We're going to take N out because we're not looking for that right like now. That's what we're substituting in. And MP. Let's see. Thought I was going to need that molar mass. Well, we'll just keep going. So now we need the density. And density is mass over volume. And we have volume over mass, so we can just flip everything. M over V equals MMP over RT. And that's how we'll get the density of the gas. That's where we're going to come in with this value. So we'll go M over V equals MM times P over RT. Now we'll take our 28.014 molar mass, grams of N2 per mole, times our pressure, because we are still following our formula here, 0850 atm, over R, which is 0.0821 times L atm times atm over K over mole, times our temperature, 298 K, and we can cancel out the K, we can cancel out the atm, we can cancel out the mole, and we are looking for our liters, so we leave that one there, and we will multiply across times 0.0850, and we get 2381 over 0.0821, we'll do our bottom numbers, times 298 is 24.47. Now work that out. 0.097 grams per liter. 0.097 grams per liter is our answer, I believe. Number 4. So a sample of carbon dioxide occupies 9,500 milliliters at STP. What is the mass of the sample? So we are given our volume, 9,500 milliliters, and we need it to be in liters. So right off the bat, we know we can go like this. 1 liter has 1,000 milliliters, and 1 over 1,000, you could probably do this in your head, but just so you know, 9.5 liters of CO2. So we are using STP values, so 9.5 liters of CO2 times 1 mole over 22.42 liters. 1 over 22.42 times 9.5 is 0.424 moles. That's what we're looking for here of CO2. And now we need to get that into grams because we're looking for mass. So moles to grams, we'll take this value, 0.424 moles of CO2, and 1 mole of CO2 has how much mass? Well, let's get our handy dandy periodic table. C is 12.011, O is 16, O2 is 16 times 2, which is 32. 32 plus 12.011 is 44.011 grams of CO2, and we will multiply across 0.0424 times 44.011, and we get 1.8. Wait a minute, did I do that right? Let me start my calculation over. 0.424 times 44.011 is 18.66 grams of CO2. And let me just do another little quick check to make sure that I'm still recording. Okay, so when I was checking to make sure that I was still recording, I accidentally stopped the recording, but we are back in business now. And we are on number 5. What will be the pressure of a sample of 48 grams of chlorine gas in a glass container of volume 2.5 liters at 25 degrees Celsius? And we will use the gas constant R equals 0.0821 here. Okay. What will be the pressure? So we're looking for P. We are given 48 grams of Cl2. That's our mass. We are given 2.5 liters, and that is our volume. And we are also given our temperature of 25 degrees Celsius plus 273 to make it into Kelvin. 25 plus 273 is 298. So we have these things and we need this. So we will take our PV equals nRT equation, and to isolate P, we'll divide both sides by V. And we'll get P equals nRT over V. So first we need to convert our mass into moles. So 48 grams of Cl, 1 mole of Cl2, and Cl is 35.453. times 2. And that equals 70.906 grams in 1 mole. Make room here. Equals 1 over 70.906 times 48.6769, or 0.677 moles of Cl2. Now we're going to plug that into our equation. So we can find P by giving N this value, 0.677 mole times 0.821 times L times ATM over K times mole times our temperature value, which is 298, all over the volume, which is 2.5 liters. And if we multiply across on the top, 0.677 times 0.8, oops, that's 0.0821, and then we're cancel all these out except for the ATM. Start over. 0.677 times 0.0821 times 298. This is why I take so long on the test. 0.0821 times 298 with 1 8 is 0.623. Wait a minute, I feel like I messed that up again. 0.677 times 0.0821 times 298. Okay. Oh, yeah, I did mess that up. 16.56 over 2.5. I already got that in there. 6.625 or 63 ATM. And that is our answer. Now, number 6. A sample of gas occupies 5 liters at 25 degrees Celsius when the pressure is 1.5 atm. What temperature is required in C to increase the volume to 40 liters at a pressure of 2.50 atm? So it looks like we have a lot of variables here, so let's start identifying them. We've got a temperature here, and we're looking for another temperature. So we know we're going to have a T1 and a T2. And we have a pressure here and a pressure here, so we know we'll have a P1 and a P2. And we also have 2 volumes. So we are going to have a change here. So let's go ahead and identify everything. So V1 is 5 liters. And P1 is 1.5. And T1 is 25 degrees Celsius. And we are looking in Celsius for this answer, so we're not going to convert this to Kelvin. Our V2 is 40 liters. Our T2 is our question, and our P2 is 2.5. So I think what we can do here is use V1 over T1 equals V2 over T2. Our V1 is 5. Our T1 is 25. Our V2 is 40. And our T2 is our X value. So what we're going to do is flip this over, multiply both sides by X, and we'll get 25 over 5. or yeah, multiply both sides times 40. And that gets x on this side, that's right. And this is T2. 25 over 5 times 40. 200. 200 degrees Celsius. I wonder if that is right. Because I know I worked this out earlier and I don't remember that being the answer. Let's see. We could also convert this to Kelvin. We want it in Celsius though. But let's just see what happens. 273 plus 25 is 298. So what if we did 40 times 298 over 5? Because maybe we need to work it out as Kelvin and then switch it back to Celsius. And then that would give us our T2. 298 divided by 5 times 40. That gives us a T2 value of 2,384. I think that's what I remember it being. So then you would just subtract 273 and you get 2,111 degrees Celsius, which is a huge number, but I think this is what's right. So this is what we'll go with. On to number 7. So an excess of sodium hydroxide is treated with 26.4 liters of dry hydrogen chloride gas measured at STP. What is the mass of the NaCl formed? Write the balanced equation first. So sodium hydroxide, we've got, that's NaOH, it's treated with hydrogen chloride, that's HCl, and sodium chloride is NaCl. We've got 1 and 1, 1 and 1, and the OH, I don't think we even need to bother with that. I think that this is balanced for our purposes. So we'll just go ahead with this. And the volume given is 26.4 liters. And we need to find the mass. Okay, so let's go with dry hydrogen chloride. 26.4 liters of HCl. And STP, so 1 mole, 1 liter, no, 1 mole has 22.42 liters. And we're looking for NaCl, and NaCl to HCl is a 1-to-1. And now we just need to figure out the molar mass of NaCl. So we will need our periodic table. Na is 22.99 plus Cl is 35.453, and that gives us 58.443 grams NaCl, and that's the amount in 1 mole of NaCl. And now we are ready to multiply across. 26.4 times 58.443, 1,542.9 divided by 22.42. Come down here for this. 68.81 grams of NaCl will be the mass of sodium chloride formed. Okay, I think that's right. Next problem. What volume does 31.5 grams of bromine gas occupy at STP? Given, always start with what you're given. 31.5 grams BR. And we need to find volume in liters. So first of all, we know that we are going to be looking for the volume. So PV equals nRT. We need to isolate the V, divide both sides by P. V equals nRT over P. So we are at STP. V equals, oh, we need to get the mass in moles of bromine, the molar mass. 31.5 grams BR. We're going to moles, and BR. $79.904 grams, and 1 over 79.904 times 1 over 79.904 times 31.5 equals 0.0. I still don't think I did that right. 1 over 79.904 times 31.5. 0.39. Just know when you've not done it right on the calculator. 0.394 moles of bromine. So now we have our moles, which is our N value. So 0.394 times R, which is our constant, 0.821 times L times ATM over K times mole. And we already can cross out our mole. And then our T at STP is going to be 273 because it's 0 degrees Celsius, and 0 degrees Celsius plus 273 is 273. And our pressure also we're going to get from our STP value, which is 1 ATM. So we can cancel out those, and we are looking for liters. So 0.394 times 0.0821 times 273 divided by 1, 8.83 liters is the amount that it occupies. And that is that answer. So number 9 is what volume of water measured at STP will be formed by the reaction of 1.31 moles of oxygen with 0.900 moles of ethane, C2H6. Write the balanced equation first. So first we know we're going to be finding a volume of water. So find volume of H2O. We are given, I'm just going to check on this real fast to make sure it's still recording without stopping it this time. And we are good. Okay. And we are given 1.31 moles of oxygen, and we're given 0.900 mole of C2H6. Now we need to balance the equation. So O2 plus C2H6 equals H2O plus CO2. So oxygen plus ethane equals H2O and CO2. And need 6, that's going to be 12. So we'll need, and then C4. Now we have 8. 7. Okay, I think that's right. Okay, so now we need to take this mole amount to a mass amount. That's right. Okay, so 1.31 mole of O2, and 1 mole of O2 has 32 grams. Times 1.31 equals 41.92 grams of O2. And then we need to do our C2H6. So we are given, actually I don't really think I need to even do the grams. Could just be going, C2H6 is our limiting reactant because there's less of it. So let's just take that value, 0.900 mole of C2H6, and let's see what we can do here. So we're looking at the moles of H2O we can come up with, because I think that it's safe to say this is our limiting reactant. So we'll go with this versus the 2 moles required of the C2H6. So H2 and O, the mass of those we will find on our periodic table. So H2 is 1.008 times 2, and that's 2.016, plus O is 16, and that's 18.016 grams in 1 mole. I'd fill that out just for consistency. Let's see what we get here. 0.900 times 6 times 18.016. I don't know, I feel like I should have gone the whole other route, but let's try this. 48.64. Seems like a lot. Oh. This is not complete. Let's go ahead and do it the other way. Always go with your first instinct. 0.900 C2H6 and C2H6. Okay, so C2H6 and H is 1.008 times 6, 6.048. C is carbon, 12.011 times 2, that's 24.022, plus 6.048, 30.07, and 1 mole C2H6. And 0.900 times 30.07 equals 27.06 grams C2H6. Okay, now this number is definitely still smaller than this one, so we were right about this being the limiting reactant. So let's go with this number, 27.06 grams C2H6 and 1 mole 30. So I guess I am kind of doubling my effort here, but too far into this now. I'm still going to go 6H2O to 2 grams of C2H6. And there are 18.016 grams in that, and 1 mole of that. And let's multiply across now. 27.06 times 6 times 18.016 equals 2,925.077. Oh, let's see. I feel like I'm doing this wrong, but we're going to keep going. Divided by 60.14. Why does that seem 27.06 times 6 times 18.016? Yep, that's it. Divided by 60.14 is 48 again. Okay. Well, that's what we're going with. 48.64 liters of H2O. And that is our answer for that one. Number 10. If a 5.5 gram sample of a gas occupies 5 liters at STP, what is the molar mass of the gas at 273 degrees Celsius? And I'm going to take a little So we are given our mass, which is 5.5 grams. And we don't know what the gas is. The volume is 5 liters. The temperature is 273 Celsius. So we're going to add another 273 to that to get our Kelvin value. 273 plus 273 is 546 K. Okay, so this one we're going to use PM equals DRT. So let's do more over here. P equals, we don't know. So STP, I guess it would be 1. What is the molar mass? That's what we're looking for. 5.5, so MM. M here is going to be our molar mass in grams per mole. D is going to be density in grams per liter. R, we know, is 0.08. Always do that. L times ATM over K times mole. And T is our temperature in Kelvin. I have everything covered here. PM, DRT. Okie doke. So, P times 5.5 PM equals D, and density is mass over volume. So our mass is 5.5, our volume is 5.0. We'll go 5.5 divided by 5, and that's 1.1 grams per liter. So D is 1.1 times R 0.0821 LATM mole. And then T is 564. So we can go K, we can go L, we can go mole. We're looking for P, which is our pressure. So we'll do this side first, 1.1 times 0.0821 times 564 equals 0.0821, 546, 273 plus 273 is 546. Okay, just need to look here. Okay, 1.1 times 0.0821 times 546 is 49.31 on this side, and then 5.5 divide by 5.5, and we get our p-value, which is 8.965 or 97 grams per mole. Mass of the gas. Yep, that is our answer. Whew. I am obviously not very good at this. Okay, and we're on our last one. A sample of 35.1 grams of butane C4H10 gas has a volume of 4.24 liters at a pressure of 2.70 atm. Calculate the temperature. Use gas constant R equals 0.0821. So, grams of butane. Volume, pressure, find the temperature. Okay, volume equals 4.24, P equals 2.70, R we know, and N is going to be our moles of C4H10. So let's take our gram value, 35.1, and convert that to moles. 1 mole C4H10 and C4H10. C is 12.011 times 4, and that's 48.044, and H is 1.008 times 10, and that is 10.08, 58.124 grams. And do the math. 1 divided by 58.124 times 35.1 equals 0.60388. So that's our mole value. So we can now plug everything in. So what we're looking for is T. So PV equals nRT. We'll divide by nR on both sides to get T by itself. And we'll start plugging things in. So P is 2.7 times V is 4.24 over N. We now have that value from here. That's 0.603. I'll just go ahead and put the whole number here. 88 times R, which is 0.0821. And T is the one we are looking for. So, do our math. 2.7 times 4.24 is 11.448 over 0.60388 times 0.0821, 0.0496. 8 divided by 0.0496 equals 230.81. So we could call it 230 or 231. Okay, I'll just do that. Although really this is probably more accurate. And that is the end. I hope you enjoyed it. Thank you for watching, and thank you for your patience. Until next time.